For the second part of animation, we need a splash of the drink which is inside the can. Make sure you're in scene 1, and let's switch to the solid mode for better performance, so we can see our results much faster. Okay. So for this splash, our inflow object is going to be somewhere behind the can. We want the splash to hit the can from the behind and make some nice interesting shape from the left and right and fall on the floor. And we want just enough of a splash to cover this frame and not too big of a domain box. Otherwise it will slow down the entire process. Let's make a new collection, and this one is for the objects interacting, any object we need for splash. Alright, let's create a cube here and scale it down just enough so that it's not visible in the front view and it hides behind the can. We are going to rotate it so that the rotation is taken in consideration by the simulation. So this is the, I believe, Z direction. So we'll increase the velocity in the Z direction so that the cube throws the water, the fluid in this direction, particularly only one. Yeah, so as you can see, we can't see the cube in the front view. Make sure it's placed right in the middle. Alright, let's go to the dynamic panel and create a fluid, assign fluid to this cube. This is going to be our inflow object. Basically the fluid is going to flow from this object. Alright, and let's create a plane for the collision. This is going to work for a floor. Basically we don't want this entire backplane to calculate in the simulation, so it's better to have something much simpler. Assign fluid dynamic to this as well and mark this as a collision. Make sure you turn on this local coordinates for the cube, for the inflow object, so that the Z direction, the rotation we have given to it, it's taken into consideration by simulation, the domain. Right. Let's create our domain object, place it right in the middle, and make sure the width is just enough to cover our frame area which is seen in the camera. As you can see, the back side of the cube is covering the entire frame very well. Okay, so the size of domain looks right. I think this should work, and we are going to assign fluid dynamics to this as well and mark this one as domain. So anything within this boundary of the cube is going to be calculated for a fluid. Leave the basic settings as it is for now, and let's just see what is happening. Click on the bake. This shouldn't take much time because the resolution is very low right now, but I just wanted to see the interaction of the cube and cans, what is happening right now. So as you can see, there is nothing exciting happening right now because we haven't given any velocity or any collision in the simulation. Yeah. So for the Z direction, let's give it a 5 velocity and let's see, bake the simulation. while the simulation is happening, you can scrub the timeline and see the results. So yeah, so 5 velocity is definitely making this work. At least we can see the fluid flowing in the direction, but the results are going to be much different in the high resolution. Let's just set up our basic stuff first before we take any high res dynamics. I mean, we bake it in high res. So yeah, I'm going to rotate it more towards the bottle, because the fluid is and the splash is happening from the right of the can. We want it to hit the can right in the center. Yeah. So at least now the flow is happening in the right direction. It's right in the center of the can, but we need to assign the collision for this can to create some interesting splash. Let's select this can which is in the front and assign this fluid dynamics and collision, mark it as collision. Yep. So there's definitely some collision happening, but I don't understand on the left side why is it creating a flat plane, because we don't have any other object colliding with the fluid. Let's see. I'll bake it again with slightly higher resolution, maybe around 120. So yeah, there is definitely some problem here. I don't understand why is this area flat. So what I'm going to do is select this can and select the volume type shell, and let's see if this works. So shell basically takes the inside and outside of the object into consideration instead of just the outer volume. So yeah, the collision is, I think yeah, the collision is much better. At least the flat area problem is solved. I hope that was the right solution. But the form of the splash is not interesting right now. You can see from the left hand side it's pretty much symmetrical. There is nothing like a random happening here, so it doesn't look natural. We definitely need to make it more organic and not so symmetrical. I'll change the velocity to 8 and bake it again, because we want the fluid to actually bounce much higher than this. So it should go like some of the fluid should go above the can. Yeah, something like this. Maybe 7. And so this process is actually like all the experimental, like you need to experiment with the settings a lot. The right velocity, the angle of the object, the collision object, and the main inflow object, the placement of it. So it's definitely going to take some time to get the desired result. I did some preparations and like it took me a few hours to get the results actually working, and I had to cheat somewhere like here and there to make the results work for me, but that's okay as long as it solves a purpose. So I'm going to give it much more random orientation to the inflow object, and I'm just trying out a best angle. So as you can see, at least the splash is not looking symmetrical here now. The part on the left is different than on the right, and the velocity looks just about right. It's going much higher than the can. Let's see in the flat view what's happening here. Sorry, let's shade it smooth. So I think all the basics are set up right now, but I'm going to give it one more try and give it slightly different angle and see what's the outcome. So instead of perfect center, I'm aligning this more towards the left, so at least so the weight of the left and right, the ratio is not equal. Right now the fluid is equal on the both sides. So to create some interesting result, what I did here was copy the back can and move it slightly forward and assign it collision. Basically what I want here is the fluid to since there will be a narrow pass, the results could be much interesting. So when the fluid collides with the both cans, there could be some small splashes happening in the center, as you can see. But I think this passage is we need to increase the distance here, or maybe the resolution of fluid. So this middle can is just for the simulation process, and we are not actually going to use this one. I'm going to test this one now with the high resolution now. First, what I think we can do is create one duplicate of inflow object. So instead of the fluid flowing only in one direction, we can have multiple objects throwing the splash. So as you can see, the amount of after increasing the resolution, the splash will look slightly different. There will be more of drops and less of chunky shapes. It doesn't just increase the resolution of mesh here, but also affects the simulation, just like the smoke simulation we do. The resolution affects the results. So it's important in between you keep taking small previews with the high resolution settings, because you can never be sure about the final results with just a 60 or 120 resolution. Alright, so these settings are working. I mean the by default settings are pretty much working. So these viscosity parameters you don't need to really change here. Default values are just working fine. In case you're simulating some thick fluid like chocolate or honey or something, you can increase this value. But for this purpose, I think the default is what we need and is working fine. We are going to animate the flow object, because right now it's continuously throwing the fluid. What we can do is animate the flow object, so that instead of continuous flowing water, we get only one splash and it stops after that. So I'm just taking one more preview here, and let's see if this is working. So right now, since it's constantly flowing, there is a lot of the splash is very big. We don't want this to be fill our scene so much and become so distracting. So let's select our flow object and we are going to animate this parameter, and let's just press I on the 0 frame and go to the frame around 20 or 30 and press I again, and here switch it off and press I. So this sets the key for the flow object. Similar to this one, we are going to create a key for the flow here. Press I, and for a few frames we want this to flow in the simulation, but stop it right here. Let's do this one for around 140 resolution and bake it. This is our main element, main interesting element in the animation, so it's okay for this to take so much time, because the rest of the things are pretty basic, like there is not much of animation, and this is like a simulation heavy scene. That's the only beauty of this shot. So as you can see, the flow is stopping right around the frame we made key on, like around 20 to 30 frames. The splash stops around here, but because of this animated value, the velocity is not working now. I think we need to increase it slightly, very little, and make this around 5.5. Let's bake this on 250 resolution now. So this one is going to take much more time than previous bake. 250 is I think final resolution we are going to use. So you can scrub the timeline if you are impatient. I like to see if there is if I can see some glimpse of what is happening in the simulation, instead of wasting too much time on bake. So our simulation is done. It took around 30 to 40 minutes here. So as you can see, the splash is looking good. The resolution is looking good. The amount of drop and everything, like the flow of object and the distribution is on the floor is looking pretty decent here. What we can do is apply a smooth modifier on this domain object, basically the fluid object, but we are going to increase the smooth value slightly higher, actually much higher than this, because we don't want any of low resolution details to come forward in the camera and make some weird shapes. It should all be very smooth. Alright. So the results are working fine, but I experimented a few more times with the velocity of the inflow object and the rotation of inflow object. So here are the results which I have already baked. So there is a very slight difference in this. As you can see, the distribution of splash is much more interesting. Basically, it's mostly because of the orientation of inflow object. I placed it more towards the left and played with the velocity a little. I think around 90 frames are simulated here. Overall, the basic parameters are same and the settings are same. I just played with the angle a little bit, so don't worry about this front, the colliding side of don't worry about this part here, because this is going to be out of focus actually, and this can actually create something really interesting, like how you throw some drops on the camera lens. It could create some interesting bokeh. So with the similar settings, I created splash for the second scene. This is what it looks like. This is for the second animation we have. Pretty much the basic same settings here, and just play it with the angle a little bit. So once the simulation is done, if you like, you can adjust the orientation of the overall splash. If this doesn't create any problem with the scene or in the camera, it shouldn't create any problem. It's not an ideal way of dealing with the things, but sometimes, you know, splash is a very organic thing, and it's very difficult to get the right shape happening on the on the side where you need it. So it's okay if you want to rotate the splash a little bit, and because this is a cylindrical object, you can easily align it. So I rotated the right side more towards the front because I like this shape here. Let's see in the scene and camera, how does it look. You can also combine multiple domains. Once your simulation is done, like, you can create a small splash and a big splash in a different scene, and copy paste it or import it here, and combine multiple splashes within one scene. You can just manipulate it like a normal regular object. You can also load your bake the cache you have, multiple simulations, and keep it in the directory and load it within the different boxes, the domain boxes. So let's just have a preview with the camera angle here. So like I said, this splash coming towards the camera is actually looking nice here, and this won't look so opaque after we use the depth of field. So I really like the floor part, like this fluid falling on the floor and the shapes on the right. I think yeah, we can, this is the final result I used for the final product. Alright, so now that simulation is done, we can start finalizing things. First we need is a material for the splash we created. It's going to be a very basic stuff like a simple principal shader. Let's select the fluid object, the domain. Alright, so I'm going to bring in principled BSDF and make it 100% the transmission 1, and no roughness, maybe very little. No need of any other parameters here because this is a transparent object. What we need is some volume absorption because we want this fluid to have some color here. Right now it's like a water, very transparent and doesn't have any color. So I'll create one more shader, bring in volume absorption and connect it in the volume. Change the color to like the cola color we have, slightly warm color. Okay, so this looks good, and maybe reduce the density a bit. So most of these materials work fine with the EV as well if you preview it, but the transmissive material and like the refractions and stuff, it doesn't give good results in EV like compared to the cycles. It doesn't look photorealistic, so you have to actually change the settings a bit. Like the volume absorption here is not visible in the viewport, or maybe like I don't know the right way how this works. Let me know if you guys know how to deal with this stuff. So the same material I'm going to assign in the scene 2 as well, what we created for the splash. Okay, let's switch to the cycles here, and let's take a preview. The splash is not seen here much. I think we need to tweak very few things in the lighting. We want this splash to have much more contrast. I think we need some backlight here. Let's go to the scene 1 and take a preview. I really like the new viewport. It gives you very quick visualizations. Like you can, even though it's not 100% close to the final results, but it helps you visualize things so much better, and instead of just a gray viewport. I mean, it's much close to the imagination. Like, instead of using your imagination with the gray objects, it's better to have this kind of results in viewport as well. So I think we can I'm going to increase the distance between these two bottles, because right now they both look very close to the camera. I want some more depth in the view. And also, like, once I move this, this was like a happy accident. Once I moved it back, I could see the middle part of the splash, which was actually going behind the second can, like this part. And as long as it's not seen in the camera, it doesn't really matter actually, as long as the final shot looks fine. If there was a camera motion, I would definitely not prefer this kind of stuff. If there was camera motion, I would instead go for a re-simulation and bake it again. But this one is like a result of desperate deadlines. So yeah, it's looking interesting, the center part of the simulation, what we just got here. Okay, so let's see if we can improve something here. Sorry, just getting used to the new interface. I keep forgetting the layout. Alright, so I think everything is set up pretty much. We are going to create a key for the camera and click on the lock camera to view, so that by mistake, if we move the camera like this, if you scrub the timeline, it resets to the final position. If you don't have a key, the camera will change. The other way of doing that is you simply lock the transformation, but this gives you a freedom to actually navigate through the view and still maintain the final position once you scrub the timeline. So unlike previous version where we used to take previews in grayscale, this looks much more fun. I actually took some previews from the viewport here and shared it with the client instead of wasting time on renders. Even though it's not close to the final result, but the overall beauty of the shot, the visualization, it gives you much better idea than animatic in the grayscale. So I really like the preview here. Just going through the view and see if there's anything I can improve. Mostly I think we are done, and we can just set up the final lighting, which it's basically a few tweaks, and we'll take some previews with the render setting and finalize the stuff. Take as much time as possible to review the stuff, because the final render is going to be very time consuming, almost like 30 minutes or 20 minutes per frame. So let's move on to the next part and finalize the render settings. For final render I used cycles because I needed something photorealistic, but for the preview purpose I used mostly EV, and both the engines have different strengths and weaknesses. So we are going to discuss the both, and So yeah, let's move on to the next part.